Okay, so let's start with the recall. This is your reflection. What happens when a charged particle travels in the presence of magnetic field? How can we define such a particle's trajectory? So you guys tell me what happens. Because in the last class, if I'm not wrong, I give you a hint. There is a Lorentz force going to be come in play. I mean, in recall, we're going to discuss about the Lorentz force again. But tell me what happens when a charged particle starts moving in a magnetic field. Very simple case here. I am asking to you guys. Suppose this is your magnetic field, and the magnetic field is going to be uniform. We are not discussing about non-uniform. What is a non-uniform magnetic field? Which is changing with respect to time either, or which is changing with respect to displacement or distance either. So this is your uniform magnetic field. First of all, uniform magnetic field. Okay. So what happens when this particular charge particle, suppose having charge q, it starts moving with some velocity v? Tell me, because this is the beginning of Lorentz force. What are the particular criteria? And more than that, if I add on one more thing, like we are going to discuss that also. This is your horizontally your magnetic field. Okay, let me draw a direction also. In this direction your magnetic field is not in this direction, because if it is going to be in this direction, okay, let's do this in this direction. Then I change the direction of this charge particle, because that is the easiest task. Okay, and now this one is your electric field. I discussed this everything in the previous class, so I want to know how much you remember or how much you know. Good evening, beta. What would going to happen if this particular charge particle start moving with velocity in this kind of scenario, where this is your electric field direction? Okay, this is your magnetic field direction, and this one is your charge particle, means velocity direction. This one. Tell me, what one thing you going to observe? And the answer is Lorentz force, so you need to explain me how and why. Tell me, beta. Because the two main things we are going to discuss based on that particular thing what we are discussing right now, like based on the Lorentz force or magnetic force, which is QVB, we're going to discuss the trajectory of particle. Tell me. Tell me, beta, anyone, please. That is very easy. I don't know why you guys take that much time. I'm asking to everyone, why are you guys sitting like this? You don't know anything. Tell me what is going to be happen here. Is this that much hard? Seriously? Why are you sitting like this? Tell me anyone. I'm asking what happen if this particular charge particle entering like this. The vertical upward is electric field direction. The horizontal right. Okay. This one is your electric field direction. This one is your magnetic field direction. And seriously? That's what I want to hear. Parikshit. The particle goes straight. Why so? If it is, why? Okay. First of all, at least someone give answer after 2-3 minutes. But the answer is why then? Why you think like the particle is going straight? Tell me. See, there are two ways. Either you tell me or either I ask one by one by just asking the name. Okay. So it's better if you start giving answer to me. Why it is going straight? There is no electric force. No, there is no magnetic force applied on that charge particle. This. Okay. Clicking this again. If this charge particle is enter in electric field, so there is a simply electrostatic force which is QE. So the effect of force is going to be something. Meanwhile, I apply or I given to you guys uniform magnetic field also. So due to this also there is a something going to be case, isn't it? So why it is going straight? Anyone else? You tell me, beta. Where are you, Yajira? And turn on your camera also. Everyone. See, even I give you the answer, still you don't say, I mean, anything. That's the worst case I see here. Okay, tell me how many forces going to be applied there. At least this answer I need, I expect from everyone. 2. Right, everyone, 2 forces. Clear na? So when 2 forces going to be applied, so what are those 2 forces? Electric and magnetic field, exactly. Okay. Sir, my camera has been defective for the past 3 days. It's okay. It's okay, Rivik. So the first force is electric force, or you can say QE. That doesn't deviate the path. But this one, magnetic force, which is QVB, that deviates the path. Why so? Because this force is not simply this, but this is the magnitude Q V cross B. So what happens? Obviously, this gives some direction. If I am not saying that V and B are perpendicular, okay. If in this case, what happens if V and B are perpendicular? If V and B are perpendicular, so I tell you this thing in the previous class also. I tell you this thing here also. This charge particle starts moving in a circle. Okay, like this. Okay, wait. Yeah, in this sense. Clear? So this is the first case. This is your case number 1. Now what happens if Q, sorry not Q, if V and B have any angle theta, So this is going to be in helical path. Now you guys tell me what is helical path. Okay, let me see. I given to you guys or not. This is third Lorentz circular helical motion. Yeah, we have this also. We have this one also. Okay. So what is a helical path? Tell me. Did you hear this particular name till now or not? Because with a helical path is somewhere look like this. Okay, maybe my drawing is not that much good, but I can draw that. Suppose this is your axis. A spring-like path, exactly. But when you know these things, so why don't you tell me till now? To whom you are waiting? This is your helical path. A spring-like path. Okay. So there are two cases going to be. Focus here, understand. If this particular okay, if this particular angle, I mean the angle between velocity and magnetic field are perpendicular, or you can say, that is good, perpendicular, or I can write here, have any theta, so that then in this scenario, this charge particle starts moving in this way, okay, in this sense. Why so? Because FQB is going to be equal to mv square by r. Okay, we're going to do the detailed study of this. If this particular charge particle have any other angle than this particular 90 degrees, suppose this is your velocity, this is your magnetic field, this is your electric field, the way I give right now. Okay, then this theta gives this particular velocity two direction simultaneously. I mean, we resolve the vectors. This is a velocity vector, so velocity vector going to be resolved here. Due to this, okay, wait. Due to this v cos theta component, we have seen this path which is going to forward, and due to this v sin theta, we have seen this particular circle of equal radius. So the radius is going to be equal here. If I didn't draw, so pardon me. Or this is going to be known as your pitch. We're going to discuss this. Is this clear? Is this clear with everyone? Okay, so we are going to discuss this and on the application of this in circular motion. When the velocity vector of a charged particle and magnetic field are in perpendicular. So we make a device, we invent an instrument that is known as cyclotron. So that is the story. That's why I want to ask. So as we know in the previous class, we discussed this thing. So I suppose you know Lorentz force. Lorentz force is the force exerted on a charged particle moving through both electric and magnetic field. That is the total force. This total force F equals to QE plus QV cross B. Okay. Simply Lorentz force, you can write it down. QE, it is a force, so it is a vector, plus Q. Q is a charged particle, so it is a scalar. This is the case. And simply, I don't know how many times I let you know still. This is your electric force. This is your magnetic force. As simple as that. Okay. And in the previous case, I already explained to you guys. Here, it is just a vectorial diagram. Is this clear, everyone? What is a Lorentz force? Lorentz force is nothing. When a charged particle is moving or starts moving, wait for a while. Maybe I'm going to. Okay, so when a charged particle enters in a magnetic field as well as electric field, and it starts moving with some velocity, so due to velocity, there is a magnetic force applied on that particular charged particle, which is F Q V cross B, and due to this electric field presence, there is an electric force or electrostatic force, what we already know, QE. So both the sum gives me Lorentz force. Is this clear, everyone? Okay. One thing I want to say, or one thing I want to tell you right now. See, whenever you guys write any particular more than 1 mark answer, either in weekly test, either in chapter assessment, or either anywhere, where whenever I need to evaluate, and I mean the questions which we going to evaluate for you guys. So try to write in a proper number of steps, first thing. And what I observe, what I want to say in the beginning, but still, I mean, this is the beginning already of the class, not, we are not moving ahead. I evaluate so many questions today. When I remember in the current electricity chapter assessment. Chapter assessment means in DRS class, we provided you, whenever a chapter is going to be finished, so we provided you, we given to you chapter assessment test. So there is a test for 1 hour or maybe 45 minutes, right? And we evaluate that. We means all the tutors, not alone. The physics, I mean, the maths tutor, the chemistry one, and the physics one also. I am also. So what I see there, if I ask a relation between, you can say, resistance and this something, or a definition of drift velocity. So maximum, I'm not going to tell the name, I'm not going to say the name. Maximum or few students just draw the diagram or very blurred diagram, they paste it down. So first of all, appreciate to each and everyone who upload the answer in either PDF form, in image form. But better that hard work, or that I mean, obviously hard work, because you write it down something, you draw something, then you click a picture, then you upload. That is going to be zero. So don't blame me uh, on the day of parents teacher meeting again. Like, sir, we do that also, whatever you said, but still we get zero. Why should I am saying right now? I mean, why I am elaborating on this point? See, suppose I ask any particular simple question in which there is no need of a diagram, and you give the diagram instead of writing the steps either on the this particular dashboard or either on this particular page or PDF format. So there is no use. That is going to be extended my work, because I need to download that particular image or that particular PDF file. Then I have to give zero to you guys. Second thing, if there is any particular question more than 1 mark, and you know, guys, which particular question is more than 1 mark. So you need to write the number of steps, at least 2 or 3. Okay, or any particular question which is only for 1 mark. So write it. Try to write that particular answer as short as small as possible, because I found this bizarre thing, like few questions are long, and that is 1 mark, and few students write really well the explanation and the everything, they uploaded the answer, and few questions doesn't need any particular diagram, but still few students upload the diagrams only. And in few questions in which you guys need to write the number of steps, the only answer they write it down, sometimes correct one, sometimes incorrect. So suppose if you are a teacher, think in this way. Okay, if you are a teacher and you give me a question, write the principle. Okay, write the principle. Let's discuss on this question because it is a subject to it. Write the principle of what it is. Write the principle of potentiometer, right? Because you guys remember that question. Write the principle of potentiometer and give its mathematical form. And give its mathematical form. Give its mathematical form. So if you're going to do this answer or solution, E1 by E2 equals to L1 by L2, and this is the question for 4 marks, and you know this also. So now you tell me how much marks you going to give me, each particular student. Give me the marks now. Okay, I'll do one more thing. I write the principle also. Okay, the principle of this is your mathematical expression, formula number 1, the mathematical expression, and principle I also write it down. Suppose, okay, suppose XYZ I write something, and I also write it down the principle. Now you tell me how many marks you guys are going to give me. because the same marks are going to give you guys, whatever you are writing down here. 1, 2, right? Neither 3 or 4. Clear? Is this clear, right? So if you guys get the same marks, don't question and don't blame me now. That's why I asked this thing. Clear na? Because that is quite a thing. If it is a chapter assessment and we deliberately give you subjective question, because you need to get at least 75% marks if you are not under any particularly if you are not lie in any category. 75% for the 75% just to sit for JEE mains examination. Then your hard work starts. So that's why you need to focus on boards also. Clear? And that's why you need to know how to write answer in subjective form. Clear this thing? Okay. Leave this thing now and come to the topic. So this is your recall Lorentz force. We already know this thing. And okay, I just okay, leave this thing. You guys get into the PDF form also, so it can remind you always. So this is your first circular motion of a charged particle in a magnetic field. So I already explained this. So what happens in a region where a magnetic field is perpendicular to the paper? What is the meaning of that? A negative charge particle travels in the plane of paper. There are two directions of magnetic field, either the right, so many number of directions, but I already explained to you guys, this is going inward and this is coming outward. What is the meaning inward or outward? Suppose my palm is a plane of paper. So if the direction of magnetic field is going in this way, so I draw this one. This is the inward one. Okay. Into the plane of paper sometimes we write, or inward also. Into the plane of paper, or inward also. Okay. And this one is outward, outward, out of the plane of paper, out of the plane of paper. Means this whiteboard is your plane of paper, and again my palm is a plane of paper. So this nib, it is going outward. So this nib outward going is the what it is in general. This nib going outward, it gives you the direction of magnetic field. Okay, get it everyone? Outward is going out. If this palm of mine is a plane of paper or a paper simply, and this nib coming inside, inward, it is the direction. Cross inward, dot outward. So whenever any particular charged particle, now it's start moving with x direction, because out of or inward is showing you guys the z direction. It is nothing. We have three directions. Okay. So okay, just give me a minute. Either your magnetic field in this direction or either in the below direction. So whenever the velocity is in the horizontal direction, it is going to be the perpendicular case. And we know this, in perpendicular case, 90 degree, theta 90 degree, it starts rotating in a circle like this. As simple as that. Okay. Clear? And the magnetic force applied on that particular charged particle is simply Fm to V cross B, that is QVB sine 90 degree, and that is QVB. As simple as that. Clear? Understood everyone? So that is the case for this. Now simply we are going to derive few relations regarding to that. That is not okay. Okay, let's understand first helical path and then we're going to find the relation. So this is when the angle between V and B is 90 degrees. Clear? This is the case for that scenario. Now moving ahead, when the velocity vector is not perpendicular to the magnetic field. So what happened? It is quite obvious, not perpendicular to the magnetic field. Vector helical motion occurs. Clear? The motion generates when one component of the velocity is constant in amplitude and direction, that is straight line motion, and other constant in speed but change its direction evenly, or you can say vertical direction. Circular motion is called. So the helical motion, or just simply, I don't know why we don't give you this diagram. I'm going to give you, don't worry guys, that's why I'm here for you. Just give me a minute. So this is your helical motion. Okay. Helical path of a charged particle moving in a magnetic field, moving in a magnetic field with angle, with the angle between V velocity vector and magnetic field vector other than 90 degrees. Other than 90 degrees. Is this clear? And you can see clearly this is your okay, let me draw in a proper way. This is your magnetic field direction. This is suppose electric field direction, but we are not considering about this. And this is your velocity direction. This one. Clear? And this one is your V parallel. V parallel is nothing beta but V cos theta. And V perpendicular, okay, V perpendicular is nothing but V sin theta. Simply what I'm saying right now, if this is your velocity direction, okay, and this one is your axis, okay, let me draw in a proper way. This one is your axis. So horizontal component, this is your horizontal component X. This one is known as your V cos theta, if it is theta angle, and this particular component is known as your V sin theta. Either you can write perpendicular or parallel, or either you can write cos theta sin theta. That is your V velocity, that is your Y component, that is your X component, and that is the resolution of vector V. Is this clear, everyone? Now one thing is going to be common here, important thing. This charged particle having the equal radius, as you can see this line, the radius is going to be equal. Okay, just give me a minute. But with equal radius, it starts moving in this way, and this particular path is known as helical path or helical motion. Is this understood to each and everyone? This one is your helical path or motion. This helical path have two radius every time and pitch also. So we are going to discuss about the pitch also. What is a pitch? Pitch is nothing. It is simply the time period of a okay. What is pitch? In total time period, this one is good. In time period, suppose we're going to find everything. The distance, or you can say horizontal distance, simply horizontal distance of a helical path, horizontal distance of a helical path is known as pitch, and pitch is nothing. How you can find How you can find this horizontal path? Simply time. Okay, suppose velocity is displacement upon time. Very simple thing. Okay, so how you can find this displacement? Velocity into time, right? I need to find this distance. So this distance is nothing, time period t capital and v parallel. Clear na? Because in this direction I have only parallel component of velocity. So beta pitch is nothing but v parallel, which is v cos theta into time period capital T. And what is time period? We're going to find. Is this clear? Whatever I am saying right now. Clear na? Everyone, because that is important. Maximum number of times you don't get question on circular path, but for this maybe you get. Even in JEE Advance also, mains also. Clear everyone? Good, if it is clear. So this is helical motion, or you can say the magnetic force, Lorentz force provides the centripetal force in a case. This is for centripetal. Okay, let me give you this one also. So suppose this is your this is your magnetic field, or in this magnetic field your charge is perpendicular. I mean the velocity is perpendicular, and in this way your charge starts moving in this case. So for that, this is the case. It's not for helical, it is for periodic motion, or you can say circular motion. Misprint, it is going to be circular motion of a charged particle. And when it is going to be, I don't know how many times I already told you guys, when V perpendicular to B. Okay, so when V perpendicular to B, so there is this particular force is going towards the center. Suppose this is your center of radius R. So towards the center we have a force which is centripetal force, and this is mv square by R. You know this thing, everyone? Okay, and here sine theta is 1. So obviously this magnetic force, which is q sine 90 degree, it is going to be qvb. Is this clear, everyone? Also, so now this particular force, two types of force apply on one thing, which is a charged particle. This two types of force apply on same one thing, which is a charged particle. So using this equation number 1, and this is qvb, using this equation number 1 or equation number 2. If we are going to equate equation number 1 or equation number 2, so okay, let me see one thing. Introduction of velocity. Now, here I need to give you helical motion thing also, but this is not helical motion. Just wait a minute. I am not going to write the same thing. Okay. So simply equating equation number 1 to 2, qvb equals to mv square by R. Solve the above equation. So R, this is your radius, and very important thing. So this one is your radius of circular path. Radius of circular path. Is this clear, everyone? And that is not small v, that is mv, capital V. R equals to mv by qb. Is this clear now? Radius of circular path. Now to find the time period, because that is important also. Time period. How you can find time period, capital T? circumference upon velocity, right? 2 pi r upon v. This is your time period. Is this clear now, everyone? So just put this 2 pi upon v, or r is mv upon qb. So that is v cancel. So beta time period is this one. Time period capital T is 2 pi m upon qb. Very important relation. There is shape. There is shape. So, okay, let me write down the whole number of things. This is your, in ABCD form, this is your equation number A, this is your equation number B, and we know this frequency also. So beta frequency is nothing but, frequency F is nothing but 1 upon time period. So that is QB upon 2 pi m. Clear? Is this clear till now? This is your equation number 3rd, or you can say C. Clear? Okay, let me check helical they talk about or not. Not. So I give it to you guys here then. Okay. Huh. So there is one change only. You understand here what it is going on? Clear na? So the radius is mv by qb, and then time period is 2 pi m by qb, and frequency is this. So as you can see clearly, in time period, important one, and in frequency, another important one, we don't have any velocity component. So the time period and frequency for helical path is going to be same. Clear? Is this clear na? The time period, because we don't have any velocity component. Okay, I do this, I go back and then I'll explain. Where I explain this helical path. Yeah, here. So as, okay, let me write down again here. Time period we find, T, which is 2 pi m upon qb, or frequency we have, I don't know why this we don't add, but still it's okay. Okay, so you can see that in frequency or in time period we don't have any velocity component, so that is going to be remain same. But what is catch here in helical path? Because the radius of a helical path is something else, not the same. Radius of a helical path, that radius of a helical path, and that is going to be mv square sine square theta divided by r. Why should I write this? Let me write it down and then I'll explain. Q v sine theta b. Yeah, this is the case. Why so? See, now here this is your circle, okay, and this circular path is just and just because of this velocity. This circular path is just because of this perpendicular component. So your centripetal force is going to be, instead of mv square by r, we have mv square sine square theta by r, because now here v is not simple v, but it is sine component, v sine theta, or you can say v perpendicular is going to be. So same here we use perpendicular component, same here we use perpendicular component. Clear everyone? So due to this, the radius of a helical path, RH, I am going to name it, and that is mv sine theta divided by q. As simple as that. Clear everyone? And if I'm going to put the formula, and if I'm going to find the pitch. So beta pitch, just directly using from here, pitch is nothing but v cos theta into time period, which is 2 pi m upon qb. So these two relations are very, very important. Very, very important. And here I use this color. Very, very. Okay. Is this clear, or should I write it down here as well? Okay, for you guys, pitch is v cos theta, v cos theta into time period, which is v cos theta into 2 pi m upon qb. Yeah, so this is the case. Clear now? In helical path, the circle is only and only because of perpendicular component of a velocity, which is v sine theta. Till now, if you guys have any doubts, so let me know. Tell me, ask me. Because after that, there is nothing much. We just going to use the application. Is this clear, everyone? Kaila, Nitra, Sai, Shrutika, Jyotsna, Shakti, Sudarshan, Sayad, Parikshit, Harimahi, Chajira, Kritika, or Trivikram also. No doubt, sir. What this particular Russian, if R changes, won't T also changes, sir? Yes, beta, but R is not changing here. Na? See, you cannot have R in this. Simple thing. In time period. Okay. If we are finding in this way, so what you are going to say, T is 2 pi V upon R, right? This your question. Na? So this V becomes then V sine theta. Then for a helical case, it is not V, it is V perpendicular. Now you put this, or then it is become RH. If you saying the good question is TH, why not TH changes? Simple, curious question. Everyone asks. Every time a good focused student asks this question. So simple thing. If I'm finding this TH, which is a time period of a helical, so I need to put perpendicular velocity first here, and then I need to put RH here. So in RH, that is V sine theta, and V perpendicular, it is going to be, or I don't need to put this RH is going to be then mv perpendicular upon qb. So automatically this V perpendicular is going to cancel. Clear na? So there is no need to take tension or worry about this particular thing of this. Okay, but good question. Clear? Everyone understood this? What he was asking? Why don't this time of helical path is changing when we know the this RH is changing? RH is not simply mv upon qb. It is mv sine theta by qb. So the answer of this question is, in time period of a helical path, this v, instead of v, we have a v perpendicular. Because simply if we are finding the v perpendicular, what is the time period? This capital T shows you the periodic time period. Means when your charged particle complete a one cycle and it starts this rotation again. Suppose it starts from this. We take this to complete this thing, going back, and then this one circle we take one time period. One circle again, one time period. One circle again, one time period again. So for that we have only V perpendicular component and RH, which is the radius of a helical path. Clear? Okay. Any other doubt, beta, in this? I write so much. Wow. Okay. Again, these ones are also important. If you are lucky, so you get question directly on this. And this one also. So moving ahead. Now introduction of a velocity selector. Now what it is, like we know the concept, like there is a, whenever a charged particle is entering in any magnetic field perpendicular to the magnetic field, so it starts rotating in a circle. Other than thing, if we have any particular magnet velocity, or you can say the angle between velocity and magnetic field other than 90 degrees, so it starts in a helical. So we create a device which is a velocity selector. We provided the magnetic field, we provided the angle orientation, and only few velocity, only few particles which certain or which reach that particular selected velocity. For example, simply what I'm saying, Fc, which is mv square upon r, and that is qvb. So from here, if I need to find velocity, so that is qbr upon m. Okay. Now I know the charge because I given the charge particle, I set the magnetic field. Or obviously when I create any particular instrument, so I set this. This means I fix this also, and the moment I change my charge particle, so it is going to select or it is not going to select according to this charge or mass, because this I can tune, this I can change according to my selector, this I can change according to my selector, this I can change according to my selector. This is fixed only. So using this formula, using this concept, there is a device which is known as velocity selector. Where it is going to be used? One simple, maybe you hear, or if you don't, so Google it, Higgs boson particle. Particle is known as a gold particle. So how we can find new particles? So there that particular velocity selector or particle accelerator is used. Okay. Is this clear? To find new particles which create mass, we need velocity selector. Or more so ever, to do simple experiment also. For example, if you are saying throwing a particle or hitting a electron or hitting a aluminium foil with to the electrons or with the electrons. So how you throw that? With the help of hand? No. Obviously with the help of some device, which is a velocity selector. Clear? Just tuning the magnetic field, just tuning the charge, you can increase or decrease the what? Up to certain range, you can go to that particular point. After certain range, you can reach another point. So that is what it is, a velocity selector. Clear? Using this simple concept. Okay, what it is written in theory wise, let's read it out. A velocity selector is a region where electric force acting a charged particle will be equal to the magnetic field force. Okay. The velocity selector is an arrangement of electric and magnetic fields. This arrangement of the electric field and the magnetic field is used to select a charged particle of a certain velocity out of a beam containing charge moving with different velocities irrespective of their mass and charge. Okay, means another example, this is one also. Like we know there is a Lorentz force which is QE plus QVB. Okay, if I am saying this Lorentz force, total force is going to be 0. So what I get, QVB equals to minus of QE. Clear? And from there I get simply V, which is minus of E by B. So just by tuning the electric field and magnetic field, I can get the velocity. This is also another case. Clear? Even I don't need the charge or mass ratio right now. Nothing I need. I just need electric field and magnetic field. Clear? So there are two certain scenarios. What is a velocity selector? Sorry. What is a velocity selector? Let us consider a charged particle of charge q moving with velocity v in uniform electric field and magnetic field, such that the electric field, magnetic field and velocity of the charged particle are mutually perpendicular. Obviously they have to be, to make this theta component get rid out of it. What is the meaning of saying that diagrammatically? This is your one direction, this is your another direction, this is your third direction. So in this direction, suppose you have a magnetic field, in this direction you have a velocity, in this direction you have a electric field. Both are mutually perpendicular. Okay, this is z negative direction. If you are confusing right now, if you are confused right now, this is the case. And this is your x. Okay, if I do the anti-clockwise, y. If I do this, z, x, y, z direction. Clear, everyone? So using this, that is why it is written perpendicular. Let us consider electric field along y direction. Wow, I do that. Magnetic field along z. Okay, just change the position or naming of v and b. So now it is perfectly what is written on the page. Okay, in the z direction we have magnetic field, in the x direction we have velocity, in the vertical direction we have electric field. The charged particle considered will experience the force due to both. We know that magnetic and electric field. We know that the force exerted on charge Q is given by, that is Fe QE QEJ. What it is staying, because it is in the J direction. Similarly, the force exerted between the by the magnetic field is, now this is very clear because it is in x direction or it is in z direction. So the guys who doesn't remember now this thing, very simple, I'm going to tell you secret here. Not secret anything. This is IJK. If you are going anti-clockwise, this is anti-clockwise. So IJ gives you K, JK gives you I. Clear? But sorry, if you are going clockwise, okay, I am saying wrong here. If you are going clockwise, so you get the positive. If you are going anti-clockwise, you get the negative. In clockwise, clock is remaining here. Clock, okay. Clock is moving like this. So in clockwise direction, you get the positive. For example, I cross J, we get K. Or similarly, J cross K, we get I. But if we are going anti-clockwise direction, what is the meaning of anti-clock? This is the meaning of anti-clock. Seriously? No. This is the meaning of anti-clock. So here what happened? Vx means I cross K. So we get negative J. Clear? I cross K gives me negative of J. So this is your due to charge electrostatic force QE, which is in J direction, and FB, which due to magnetic force Q. This is your separate story. Keep aside. FB equals to Q V naught B in negative Z direction. So this is your equation number 1 and this is your equation number 2. Clear? Now you can see that one force is in the positive J direction here and one is in the negative here. Clear? Or specifically, I need to explain so many things to you guys. I don't expect sometimes, but I don't need. So this is your I direction, this is your J direction, this is your K direction. Electric force is in this direction, Fe, and beta magnetic force is in this direction. Okay, I took the same color. Is this in direction, Fp. So obviously both the forces are in opposite, so they're going to cancel. The vector sum is going to be the subtraction. Clear? So what happened then? The same thing I got it. The same thing I write it down. Then we already say that this Lorentz force is this. We need to put 0. So the moment we put 0 and put the values, or you can say in equation number 3, in equation number 3 when we put equation number 1 and 2. So we get this. So obviously, with the help of only and only electric field, we get the velocity, which is the velocity selector. Okay. Clearly, the electric force and magnetic force are opposite in direction. For the velocity selector, we follow the condition where both the forces must be equal to each other. Then from equation 1 and equation 2, I said in a reverse sentence. What I said, they write Fe equals to Fb. And when it is going to be, so obviously because both are in opposite direction, so the Lorentz force is going to be 0. I said we put Lorentz force 0, which is summation of Fe plus Fb, and obviously they are going to be subtract because it is negative sign. Okay. So either you write this or either you write this. Clear? So then velocity is going to be E by V. Simply. Clear, everyone? Good. Okay. The field of velocity selector, uniform electric field, uniform magnetic field. So this field is produced by the upper plate with the wrong side at the lower plate. Okay, this is this cos. This is just the formation of this particular element field. So just read it down. I'm not going to explain. This cos leads to the formation of a platform facing upward in the image. Uniform magnetic field. This field is equally located between two charged plates so that it can be direct inward or outward. Means for uniform electric field, for non-uniform electric field, whenever we're going to construct this particular velocity selector, we need to take care of these things. Speed selector limit. The weight or charge of the particle is not considered before the filter has passed. All uncharged particles pass through the filters. Okay. Means obviously if uncharged particle we apply, so there is no electric force is going to be applied there. So they are going to be passed. What is the meaning of this line? The meaning of this line Fe is 0. Clear? Because we don't have charge. F is what? 2E. And when what is this is uncharged particle means Q is 0. So automatically that is going to be 0. And when it is going to be 0, so magnetic field, this, as we already described this, so velocity is not going to be countered, or you can say every charged particle passes through the filter. There is no filtration then, as simple as that, because then magnetic field is also 0. Clear? For chargeless particle, we cannot take that particular concept for the filtration of velocity. Velocity selector. If there is no filter, so we don't need to select every particular charge part unless chargeless particle is going to pass. Clear na this thing? Simply one analogy. If there is no security guard, so everyone can enter in the movie hall. As simple as that. Okay. You don't need to worry about this. Speed selector uses question. I need this thing. Okay, this is just another information. Let's discuss this. The speed selector is used with most spectrometers to select newly charged particles of a certain speed for investigation. Like I already tell you guys why we need this. We need this to find the new charged particles and to do the experiment with the high moving charged particle, which can be altered only and only by changing the electric field as well as magnetic field. Okay, so it uses a mathematical calculation where the opposing electric and magnetic fields correspond to the speed of a molecule. This is way it allows the particles to move at just right speed. Means speed or selector uses, what are the uses? Whenever there is a new particle going to be invented, or if we try to invent new particles, so we need to give the certain velocity, and just by providing that much electric field as well as magnetic field, because we have this velocity for any particular velocity selector, v naught equals to E by V. So we don't need to worry about charge, we don't need to worry about mass of a charge particle, we just altering. Yes, beta, break, wait, I am speaking continuously, I don't need break, you need break. What happened to you guys? Eh? You are just sitting at your home, writing the thing, you need break. I know, I know. I am speaking at least 5 words per 2 seconds. Now count the number of words in 1 hour. 60 minutes into 60. So if I just speak 1 word per second, then calculate this thing. 60 into 60. 3600. I speak that much word in an hour. Got it? I know I need to give, but please don't mention in next classes. It's not somewhere written. We know this thing. You guys need a break and we guys need a break too. Okay, last line. You distract me sometimes, beta. I mean, not you, the comments or chats like here. Okay, where I was. So velocity selector, speed selector uses is this, as simple as that. Okay, this is your question. Read this. Very easy. I think a velocity selector is used to select alpha particle of energy this much from a beam of containing particles of several energies. The electric field is this much. What must be the magnetic field strength? Okay. So one hint I'm going to give you guys here with the energy of this kinetic energy, because you know this. Sorry. Solution. Kinetic energy given. Okay, 200 keV. Okay. And kinetic energy is also, we know this, half mv square. But it is going to be used for joule. So you need to convert this into joule first. And how to convert 1 EV into joule? I think you know that. If you don't, 1.6 into 10 to the power. Sir, sorry, I know. It's okay, beta. 10 to the power minus 19. Either multiply or either divide. I need to check this one also, because I'm confused in this. Maximum number of times. EV, this. Okay, B, this. Magnetic field is given. The mass of alpha particle is this, the velocity of the alpha particle. Where it is given? Okay. But it is not mentioned. So, okay, tell me you guys in the break, you can, how you can, obviously velocity is finding in this way. First of all, this is very common. Mass of alpha particle, in each particular paper you get in the just below the table, wherever the guidelines are written down. So mass of alpha particle is nothing but 2 electron, 2 He4. This is your alpha particle, 2 He4. So simply the mass of 2 helium, and what it is? Mass of 2 electron. Okay, let me check. Yeah, the mass of alpha particle, 2 proton, or 4 it is, 1.67 into 4. 1.67. 4 sevens are 8. 4, 4. 4 fours are 6. Huh? So mass of alpha particle is 6 point. Okay. 4 proton or 4 electron, 4 proton, that is 6.48 or 6.68. Okay, yeah, 6.68. What happened to my calculation today? 2 carry here is going to be, and then here is going to be 6.68 into 10 to the power minus 27 kilogram. Just give me a minute. I need to check this and then confirm, because sometimes maximum time 1 ev to joule multiply. I know this. Good. Whenever you need to convert 1 electron volt to joule, okay, so 1 electron volt is nothing but 1.6 into 10 to the power minus 19 joule. So here it is kinetic energy in electron volt. So kinetic energy in joule, it is simply it is k kilo 200 into 10 to the power 3 into 1.6 into 10 to the power minus 19 joule. Clear? You have a mass also with 4.668 into 10 to the power minus 27 into V square. From here you can find V and then easily you can find V because V E by V. Okay. So I already give you the answer. You just need to do the calculation. Now you can guys now we can take break. Okay, beta. In break, you can do the calculation and there is a break for 5 to 10 minutes, not more than that. Clear everyone? After a break, we're going to discuss the important thing and that is cyclotron. Okay. So just find V first and then with the help of V, because V equals to E by B, we need to find here final thing, we need to find B, which is E upon B. So do this also. Hello, hello, hello. Am I audible? Hello. Hello. Okay. So see here they just directly given to you guys the velocity, but the formula how to find velocity I let you know already, right? Darshan. the mass of an alpha particle 2He4. Why it is mass? What I am doing. Simply, as you know, the total mass of an atom or a particle is the sum of proton plus neutron. So we have this 2He4. This is your alpha particle, and as you can see, 4, 2 proton, 2 neutron. So 4 into multiplication on 1.67 into 10 to the power minus 27. So that is why it is mass m alpha. This is your velocity. You can find with the help of this v alpha, and then with the help of this v equals to E by v, you can find this, and that is 290 millitesla. Milli means 10 to the power minus 3. Is this clear, everyone? So that is how you can find this. Clear? I hope this one is clear for each and every one. Moving ahead, this one is your simple one again. Self-practice. A charged particle is moving in a uniform magnetic field. This, if it has an acceleration of this, then find the value of alpha. Uniform magnetic field, and this is your acceleration. You need to find the value of alpha. One hint I can give to you guys here, how you can solve it out. This is simply, whenever the charged particle is accelerated, so the force is 0. Then you need to this QVB going to be 0. So just this is the vector thing. Vector thing means the vector product of this and this is going to put 0, and then simply the alpha value you can find it out. A magnetic force is perpendicular to magnetic field, so F dot B must be 0. So 2 alpha minus this is going to be 0. Okay, when a charged particle is moving in a magnetic field of this and has acceleration, so simply F is ma. Okay, one force, and Fb is equals to QVB, or you can say in this way. So okay, so what it is, simply acceleration into magnetic field is 0. Why so? Because we know this velocity. Okay, when this particular acceleration comes on, only and only when this particular charged particle starts moving in a circle, and when it is moving in a circle, you know this thing, when it is moving in a circle, centripetal acceleration. What it is? This is your centripetal acceleration, AC, v square by r, if I'm not wrong. Okay, MAC and centripetal force. Okay, so only and only this happens when V is perpendicular to B. So V, and how you can find A. So when V is perpendicular to B in a simple manner, then AC is also perpendicular to B, which is a magnetic field, and doing this we get the answer D. Okay, so this is very simplest, but understanding what it is saying, that is hard thing. So as magnetic force is perpendicular to magnetic field, F dot B, or you can say simply instead of F dot B, alpha dot B, that is the, why should I write alpha everywhere? Acceleration dot B is gives you 0. Why so? Because acceleration is perpendicular to magnetic field. Simply. Is this clear, everyone? So when you do the dot product, I into I, 2 alpha minus 4 into 3, 12, and simply you can find this. Is this clear? Tell me please, concept wise I'm asking. Calculation is very easy. Clear now? That is why the correct answer and the value of alpha is B. Okay, one thing I want to tell you now, on the Tuesday class, I am going to be absent. So on behalf of me, another teacher going to teach you, Susma ma'am. We're going to introduce properly in next chapter, but still I am not here. So she is going to teach you guys. Okay. cooperate with them, cooperate with us. That's what I'm saying. Because I know you guys are not answering anything, and sometimes it's so irritating. Please cooperate with her because she doesn't know you guys. I know with whom I am talking, with whom I expect the answer. So that's why I'm saying, okay, like you cooperating with me. Sometimes you don't, but still maximum time. So this is our application for the concept. What we are whenever any particular charge particle is moving in a magnetic field, having the velocity vector perpendicular to this magnetic field. So on the basis of that, there is a device which is known as cyclotron, and this is important again for both, for you can say experimental thing, and to know why we are learning this concept even. So what is a cyclotron? First of all, I think that is pretty much clear. It is a device which is going to use the concept of this, and with this we just accelerate the charge particle, or simply if I am writing in a simple sentence, it is a instrument, or it is a device. It is a device to accelerate. It is a device to accelerate charge particle. Charge particle in presence of obviously magnetic field. In presence of changing in presence of magnetic field and electric field. Is this clear? So electric field is going to be alter, and due to this, the sign convention of when electric field is going to be alter means we here use AC current. So obviously, then due to this AC current, electric field is going to be alter. So FE is going to be positive and negative both. Okay, and due to this, every time starting from starting from this point, this circle is going to increase, again increase, again increase, again increase, again increase, again increase, and when we know this is the approximate velocity what we required, we throw it out. Is this clear? Is this clear, everyone? So simply, as you know, in this, as you can see here, again I'll let you know. From here it starts this one circle, bigger circle, bigger circle, bigger circle. So this is simply based on helical path, as you can see. Not helical path, because in helical path the one thing is common, radius is common. So it is a combination of a spiral thing. This, 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 and then get out like this. Okay. So working principle. This is not going to help you out, because if I am not wrong, cyclotron or toroid, both the things deduct or removed from the CBSE portion. But still, if you want to, learn in a proper way, we can do that. A cyclotron accelerate a charge particle, beam using a high frequency altering voltage. So altering voltage gives you this, what I'm saying now, Fe equals to plus minus QE. Because if your voltage is altering, or you can say altering voltage provides me altering, what is the spelling? ALTER, alternating voltage. What is the meaning of this? This is your voltage alternating, positive, negative, positive, negative. When you have alternating voltage, this one. So obviously you have alternating electric field also, right? So with the alternating electric field, you have alternating electric force also, and that is why I write it down here, positive, negative. When electric field is the positive, so it is positive. When electric field is the negative, so it is negative. Positive, negative. Clear this thing? So alternating voltage which is applied between two hollow D, this is D's. Okay, in this way you can understand more better. This is your two hollow D's. This left hand side look like D now, and right hand side look like D also. Okay, D-shaped sheet metal electrodes as known as Ds inside a vacuum chamber. The Ds are placed face to face with a narrow gap between them, creating a cylindrical space within them for particles to move. Particles are injected into the center of this space. These are located between the two poles of an electromagnet, which applies a static magnetic field perpendicular to electrode plane. Okay, what is the meaning of saying this? Suppose this is your electrode plane. Yeah. Suppose this is your electrode plane. So the magnetic field corresponding to that is in the z direction. What is the z direction? Suppose again, how many times I need to see? Suppose this palm is my 1D and another D. Okay, this is the plane of electrode. So this is your perpendicular magnetic field, either above, either downward. Clear? Clear everyone, right? So either in the positive y direction or z direction, because it is in the x direction. It can be positive y or positive z, negative y, negative z. The main thing is perpendicular to the electrode plane. Clear? So this is your working principle. Clear this thing? You can read this thing again, and if you have any doubts, you can ask me. Then the magnetic, this is going to be a something theoretical part, a long enough. The magnetic field causes the path of a particle to bend in a circle due to the Lorentz force perpendicular to the direction of motion. Okay, good enough, fair enough. An alternating voltage of several thousand volts is applied between the Ds. The voltage creates an oscillating electric field. I already explained this thing. This is your oscillating voltage. So this creates an oscillating electric field. As simple as that. Okay, simply why so? Because E equals to minus dV by dr. And if I am doing here, simply for magnitude wise, that is V by L, or here the dimension of D or the radius is going to be alter every time according to the path, according to the position of a charged particle. Okay, for example, why this R is altering? Okay, one thing, as you can see here, here R is something else, for another R something else, another. So that is the meaning, and that is why when your voltage is alternating, changing, so your electric field is also changing in equal amount. Clear this thing till now? So electric field in the gap between the D's accelerate the particle. How it accelerates the particle? Because every time you have a high electric field, because V is going to be changed, and similarly R is going to be changed. So when it is 1000, so electric field is high, and due to this particular force, again Fe, which is equals to QE, so it accelerates, and the moment it accelerates, so it starts from here, then it's coming in the bigger, then it's coming in this bigger, and then more and more in this way. The frequency of the voltage is set so the particles make one circuit during a single cycle of voltage. Like this particular frequency is in which, what is the frequency of a voltage? This is your frequency of a voltage. So is this, this is going to be set in this way, like from 1D, from here to here it goes, and then from here to again another D it goes in this way. To achieve this condition, the frequency must be set to the particle cyclotron frequency. Now what is cyclotron frequency? F equals to QB by 2 pi m. Where it came from? Simply understood. I already tell you, whenever any particular charged particle is moving in any circle, so that is have a time period which is 2 pi m upon QB, and so frequency of that is QB upon 2 pi m. Why so? Because we know frequency, F is 1 upon time period, hertz or second inverse. Clear now? So we have B, we have Q, we have M. Magnetic field is 10. Q, electric charge of particle. M is relativistic mass of a charged particle. And one frequency is we set already with the help of this. What is this? This is my alternating voltage. Simply I use this sign in a circuit. Suppose this is your, so this is my this alternating voltage. So obviously you can see that this is in the wave form. So whenever any particular thing is in the wave form, so from one crust to another crust we have a wavelength, and the time duration to go from this particular position A to B is known as time period, and obviously the reverse of this time period is frequency. So this frequency is set in this way, so that is going to be matched with this cyclotron frequency, and with the help, okay, with the help of this, okay, since again I'm starting, what happening here, what I'm doing, I need to use a pointer. What happening here, we apply in this way, understand, just give me a second. Here we apply something this, which is a alternating voltage, right? This is your alternating voltage. That can be V naught sine omega t. What is sine omega t? With the help of this, your voltage is moving in this way, sine function. So there is a one frequency of voltage which gives you alternating electric field, and there is one frequency of this due to charged particle moving in 2b upon 2 pi a. One frequency is this. So due to this changing or alternating electric field, suppose this is electric field alternating, your particle starts from here. Your particle starts from here. It covers this path. The moment it reaches here, the electric field is changes, and now this particle attracts towards this. Again this coming in this way. The moment it reaches here, again electric field is changes. The bigger circle it cover. The bigger circle it cover, the bigger, and when we reach that particular velocity, what we need, what we required, we throw it out. Clear? This is the simplest example. This is the simplest explanation. Explanation I provide to you guys. If you have a still doubt, so you can ask me. Nothing more than that in this they ask. But it is important because of this simple formula. Obviously, they give you the charge to mass ratio, and they ask other frequency. They ask, they provide, they give the charge mass ratio or give you the magnetic field. Then they ask this, or they can ask in reverse. They give you charge mass ratio and give you the frequency. Then they can ask magnetic field of a cyclotron. Clear? But the concept is we put, okay, this is my charge particle. This charge particle is here. It starts moving in this way. Then this, then this, then this, then this, then this, then this, then this. Now your simple question is why it covers this excessive circular path again and again, right? This is question. Or any other. If this is, so I'll explain this, or if you have any other. So very simple, because you can see that my electric field is changing every time, right? So this half electric field, I apply this voltage or electric field in this way. So from 1D which means this half portion, my charge particle only cover this much till here to here. The moment it reach here, my electric field change. The moment it change, it cover a bigger picture, or it covers a bigger circle in this way. The moment it comes here, it cover a bigger circle. The moment it means the moment the charge particle reach here, it cover a bigger circle. Same bigger circle, same bigger circle, same. Okay, same this bigger circle, then again this bigger circle, then again this bigger circle. So obviously you know this thing, simply mv square upon r equals to qvb. So from here v equals to 2b qb r upon m. The more the radius, the more the velocity. Clear this thing? Why we are doing this thing? To increase the velocity. As you can see, the more the radius, it starts from here, then the radius is this, then this, then this, and in each particular pattern, in each particular cycle, it is going to increase. So the moment we reach up to the highest radius, okay, the moment we reach up to the highest radius, this is, okay, this color is not suitable here. The moment we reach up to the highest radius, this is your R max. So at R max, I get my V max, velocity max, because Q by M is fixed, B is fixed. So my velocity is depend only radius only. If everything is fixed, if I'm saying here, charge by mass ratio is fixed and magnetic field is fixed also, what is remaining then? Then only and only I have velocity of max is any constant k and R max. And this R max is depend on this electric field. The more I apply electric field, or you can say the more powerful I apply this alternating voltage, the more powerful I get this electric field and the more radius I get. Is this clear? This K is nothing, QB, here K constant is nothing, QB by M, because we fix this thing. In general, we fix. Because once you select the charge, so automatically according to the charge particle mass is select and magnetic field is also selected, or you can say fixed. Clear this thing? Everyone, this thing is clear now. Now what is happening here? So in this manner, whatever the written theory is, other than this, I already explained you what happening here. If you have still questions, you can ask me. Clear? So this is written in these 3 pages. If you read this after this class slowly, you can go. You can get it. What I am saying. Again, I am telling you guys, cyclotron is a device to get the accelerated charge particle. How you get this, I already explained twice. Clear? Good. Expression. Now this is again important thing. Expression for particle energy. The energy of the particles depend on the strength of magnetic field, obviously, and the diameter of the disc. Why the diameter of the disc? Because I do this thing, V is nothing but QBR upon M, right? This is your velocity. And the higher the velocity, the higher the energy. Higher energy means kinetic energy in simple. So it depends on, okay, from this, my V directly depends on magnetic field. My V directly depends on R. R is radius of a D. The maximum, or you can say the more broader D, the more larger my cyclotron is in shape. Suppose this one cyclotron of this shape and one cyclotron of this much shape only. So obviously the A cyclotron have more radius. If I make a D also, this is your D, this is your D. Okay. Obviously cyclotron A have more radius as compared to the cyclotron B. So obviously the particle, the particle have more velocity because it is directly proportional to the radius. Clear na? And what is radius? This is your radius, RA, and this is your radius, RB. And charge by mass is constant every time, but still if you want to do that, velocity is inversely proportional to the mass. Means if you lower down the mass, if you get any particular particle, if you choose that particular particle which is very lesser mass, and what is the least mass, you know, mass of an electron, 9.1 into 10 to the power minus 31 kilogram. I don't think so you know lesser mass than this, and this velocity directly proportional to charge also. So these are the factors, and based on that we find the energy. So expression for energy, as we know, Fe, that is written wrong, that is Fc, not E. Centripetal force, mv square by r. The force is provided by the Lorentz force, Fb, on the magnetic field B. Fb equals to QVB. Equating these equation, mv square upon r, QVB. V is QBR by M. I already given to you guys. So how you get energy? As simple as that. Energy is nothing but, because we are finding here kinetic energy due to the motion. Put the value of V. V is this. The moment you do this, this is your energy. And believe me, this is very important for me. Clear? I don't think so. After explaining that much, you going to be have a doubt anything important. Clear now? This one. Clear, beta? Shayad, your facial expression tells me you don't get anything. Is it so? And your mouth tell me the last PTM I need to take care more about. Why don't you ask? Tell me now. Is this clear? What I'm saying? Good. Okay. So we already know how to find velocity. Just simple these two relations, centripetal force and QVB. Then you can find V, QBR by M, QBR by M. And with the help of E, which is half mv square, you can get this. And expression for particle energy. Okay. This is going to be not expression for particle energy, we already do. This is going to be the application of cyclotron. Limitation, let me see, magnetic mirror, what we have. Oh, we're going to finish in a time and question. Okay, just give me a minute. So many headings. So this is going to be this. This is going to be what? Application. Application for the application of cyclotron. For several decades, these were the best sources of high energy beams for nuclear physics experiments. I mean, these were what cyclotron. Instead of these, cyclotron were the, I mean, we use cyclotron in nuclear physics experiment. However, these are still in use for this type of research. Treatment for cancer. Most important one, cyclotrons can be used in particle therapy to treat cancer. What is the meaning of that? What is the cancer? Whenever any particular disease is going to be that much damage, we cannot do the surgery for that. Neither we can remove that particular part. So we hit the few amount of few particles to burn that tissue, or to what I say, to use these high energetic particle for the treatment of cancer. Okay, dead cell. Using the ion beams from cyclotron to penetrate the body and kill tumors by the radiation damage. Is this clear? Simply by applying that high much energetic charge particle, we kill that particular tumor or that particular tissue wherever on the particular body we find this cancer. And maybe you hear this terminology in chemotherapy. What? Okay, chemotherapy is what? Whenever there is any particular cancer patient is going for a chemotherapy, so she lose her hair. Why so? Because of these high energetic ions, high energetic particles due to the radiation. Clear? So there also we use cyclotron. Now, are there any limitation of cyclotron? Yes, cyclotron cannot accelerate electrons because electrons are of very small mass. Okay, a cyclotron cannot use accelerate neutral particles simply because that this like this changing electric field and this changing voltage, even you apply, but then it is going to be zero. Why so? For neutral particle, Q is zero. So that is the reason. It cannot accelerate positively charged particles with a large mass due to the relativistic effect. What it is, as we know, V equals to QBR upon M. So if M is going to be high, as simple as that, V is going to be less. Okay. And okay, we don't need to discuss this. What is the relativistic effect? When any particular charged particle starts moving with the speed of light, so it deviates with its mass. That means for any particular particle, the rest mass is something else, and the mass with which it is moving, it is something else. That particular mass is known as relativistic mass. Here, if any particular student uh, going to take anything which is related to only and only core physics, then she understand what I'm saying right now. Simple one thing I'll let you know. As we have a relative velocity, right? From the observation, from the point of observation, velocity is going to be changed. In the same way, if any particular particle, if any particular object starts moving with very high velocity, which is up to the range of the speed of light, you can say 0.12 c. So then at that particular range, your mass, your energy, your length is going to be altered. That is relativistic. Clear? And this mass of a particle is nothing m naught plus 1 upon 1 minus v square upon c square. Okay, m naught I know to take. So due to this is your mass and this is your rest mass, m naught. So that's what is writing down here. But in general, we just talk about this because maximum number of times in day-to-day life, in practical life, we don't, I mean, we cannot move with the speed of light. Why so? Because everyone knows speed of light is this much. Clear na? So that is the everything scenario. Now this is magnetic mirror. What is a magnetic mirror? Magnetic field arrangement in which the field intensity varies along a field line. The mirror effect caused the charged particle to bounce back. Like charged particle start bouncing back, behaving like a mirror. That particular device is known as a magnetic mirror. Particle to bounce back from the high field area. Such phenomenon is called magnetic mirror. Okay, this is just for the application part or use the helical motion. Questions from that they don't ask much. So for new thing, I give it to you guys. So magnetic mirror is a device, is a concept in which we use helical motion, as you can see. Okay. Here in this particular type of helical motion, the radius is not constant, obviously, like the same in the previous case we see in the cyclotron phenomenon. In the same way, when a charged particle starts bouncing back, like suppose it is hit here and then bounce back in this way, hit here and then bounce back like this. So this is the concept of magnetic mirror. Okay, if we denote the particle rotational frequency, which is t equals to 2 pi by omega 1 by v, the pitch of the particle. Okay, here this magnetic mirror, because we already discussed about helical pitch, helical velocity, and so and so. So on the behalf of that, they already explained. Like the pitch of a particle is the distance move along the direction of the magnetic field in one rotation. Then pitch is nothing but v parallel to the time period, which is, we already know, time period is 2 pi m divided by qb. Here v is parallel, which is v cos theta. Okay, maximum number of time it is written down in this format, but the general meaning is this, v cos theta, where v parallel is the velocity parallel to the magnetic field. Okay, and t 2 pi by omega 1 by frequency. This is frequency, not v. Don't confuse yourself in this, because f equals to 2 pi by omega, right? This is angular frequency. No, omega equals to 2 pi f. This is the correct, and omega equals to 2 pi by t. So from here we get this, t equals to 2 pi by omega and 1 by t equals to f. So 1 by f. This is the calculation. Clear? So this is done by my side, and this is your question on the cyclotron. think theory part is done. Okay, let me check once. Yeah. Okay, do this. Not this one. Easy one, because on cyclotron, on solenoid and toroid, we get the simplest question. But the main thing, you just need to remember the formula even. A cyclotron is used to accelerate protons. If the operating magnetic field is this, radius of the D is this, kinetic energy of the accelerated particle. Everything is given. Q, you know, mass it is given. Q, instead of Q, you use E, and then it is easy, everything. We just do this. Q, what is the formula? Q square, B square, R square upon 2M. Everything you have. Q equals to E, D is given 1.0 Tesla, right? And then R is also given 0.6 meter. M is also given. Do this. And you need to tell me MeV. Obviously, you get this thing into joule. So to get in electron volt, 1 joule to electron volt, simply divide with electron. Electron means this. Okay, do this and tell me. I already write whole answer. Do this and tell me the correct answer. In mega electron volt, 10 to the power 6 electron volt. Do this bit and tell me the answer quickly. Then you need to do this. Then we need to do this. What it is? Class assessment. B. Okay, let me check. I don't know the answer, beta. B. Yes. R is mv by qb. K is, okay. How they, you can write it in this way also. I teach you, I think, this thing in first. R equals to mv upon bq, right? We know this thing. Kinetic energy is mv square. So 1 by 2. Okay, how you can do that? Multiply and divide with mass. So what you get? P square upon 2m. What it is? P equals to mv. Okay, so from here, P square becomes 2m into k E, or you can write directly kinetic energy. So that is 2m k under root. They use this thing, and again this thing. So it's better, whatever the relation you remember, the correct answer is this. Okay, find this one. An electron in a metal has an effective mass. This is effective mass 0.1 m naught. This is me or m naught. If this metal is placed in a magnetic field of magnitude this, cyclotron resonance frequency omega c is mostly near. What do you need? Okay, resonance frequency, simply frequency, that is qb by 2 pi. Everything you have, I guess, if I'm not wrong. Instead of m, you need to put 0.1 me, mass of electron. Q you have electron. B you have 1 Tesla. A, B, C, D, E. Nice. That much. Tell me the answer. Instead of m, you sorry. Then everything you have then. Q equals to E. B is given to you. One, two, three. 1, 2, 3, 4, 3, 4, 7, 7, 3. Yeah. Tell me the answer, beta. Or should I tell you? Let me check. I'm doing the correct or not. Sometimes I don't. QC by QB by F. Okay. B. But answer is B. Yeah. 10 to the power 12. B. 10 to the power 6. How it is not going to be. If you just thinking about power. Simply, you don't need to do anything. See, B is 1, M is something which is into the range of 31. You don't need to do anything other than this. Simplest way to find the answer. See, everything can be multiplication or so and so. First of all, if you are not coming in the range, so that is not going to help. Clear? This is for everyone. See, the moment I write the formula, your main thing is this and this. This is in the range of one order, or this is also. I got C actually. The answer is 10 to the power 12, which is D. Okay. It's okay. 19 and 31, 12. Simple. And Q is 1.6, and then 2 pi M, it is 0.1. So it makes it 6.28, 2 pi into 0.1. So that is 0.628. And the numerator we have, this is all about denominator, constant. And the numerator we, okay, 1.6, B is 1, and then it is 0.68. So it is automatically 10 to the power 12 is going to become, not 11. Clear? Because it is 0.me, not simple. Range automatically you can get it down. And from here you can get this also. Clear? Okay. So in this way, the correct answer is D, not B or C. This one is D. So in this way, we cover this particular introduction. Okay, this is magnetic field and motion in combined electric field and magnetic field. How we have circular one and helical. Okay, I hope and believe you get and you understood really well in both the ways. Fields, like fields are circular and helical, then velocity, selector, and then cyclotron, and the application of cyclotron, and the energy and velocity of cyclotron also. Okay,